Hello Year 9s and welcome back to Math and Magic. In today's lesson we're continuing our topic of indices and surds, and what we're going to be looking at today is our first set of index laws. So what we want to do today is we're trying to understand and apply index laws, and by the end of today's lesson we want to be able to recognize the index law for multiplication and division and simplify expressions by applying the index laws for multiplication and division. So last lesson we talked about indices and how indices is just a way that we can shorthand or write really quickly repeated multiplication. And so with our indices we've got a thing called our base, our number at the bottom, and this tells me what number is being multiplied over and over again. And at the top we've got our index, our power, or our exponent, all words that mean the same thing. And this just tells me how many times it's being multiplied on itself. So what we're going to be looking at today in the next couple of lessons is a whole bunch of these things called index laws. Now, an index law is a set of patterns or rules that occur when performing operations with indices. So when we do some specific operations with indices, what we notice is that there's a few patterns that we start to notice when we perform those operations. So what we're going to be dealing with is figuring out what those patterns are and applying those patterns. So a quick note before we begin. A term without a power has a power of 1. So here, a term without a power just has a power 1. So for example, if you ever see a number or a letter by itself, so a number or a pronumeral, so let's say for example A, that's written by itself. I didn't say this last lesson, but actually this can be written as an indice. This is actually A to the power of 1. So if you ever see a number or a letter by itself, it just has a hidden power 1. So for example, if I have 7 just by itself, that just means I have 7 to the power 1. And that's going to be really important for us when we actually apply these index laws in a moment's time. Okay, let's start off with our first set of index laws, our first index law. Now, our first index law is this one here. Oh, I'm going to just adjust myself. Our first index law is for multiplication. Now, when we multiply terms with the same base, we add the powers. So what this looks like is our index law for multiplication is if I've got two indices with the same base, so I'm going to both write them as A. So A to the power of M times A to the power of N. Notice here they have the same base. They both have the base of A and they've got different powers, and here we are multiplying them. We are multiplying these two indices. When we multiply these two indices, what we do is we add the power. So here this just becomes A, that doesn't change, the base still stays the same, and becomes M to the power M plus N. So if you ever see that you're multiplying two indices, we just add the powers. The base doesn't change. Also, a few things here. We need to make sure that the bases are the same first of all. If we've got different bases, we can't apply this rule. The second thing is, when we write this as a multiplication, when we apply this multiplication, the new base at the end, so notice here, this A doesn't change. It doesn't become 2A, it doesn't become A squared, it just stays the same. All we're doing is just adding the powers together. So we're adding M and N to become M plus N. So that is our index law for multiplication. So let's actually apply this for a few different scenarios. So here, let's have a look at these questions. I've got 4 of them here. So simplify the following, leaving your answer in index form. So let's have a look at the first one. The first one, I've got 3 to the power of 6 times 3 to the power of 4. Notice here, they both have the same base. And because they both have the same base, we can apply this law for multiplication. We're multiplying them, so here, this just becomes, well, when we multiply terms with the same base, indices with the same base, all we do is we add the powers together. So here we're going to write 3 to the power 6 plus 4. Okay, so that just becomes 3 to the power 10. So notice here we don't multiply so what not to do, so this is what you shouldn't do. Because we see those, you might be tempted to go, okay, I'm going to multiply the 3 and the 3. And so this becomes 9 to the power 6 plus 4. We don't do that. We want to make sure that the base stays the same. So firstly, we check that the bases are the same. And then we go, okay, we add the powers together. We don't do anything to the base. Okay, let's have a look at the next one. B, I've got x to the power 4 times x to the power 5. Now here, once again, we've got the same base. We've both got x's here. And so here, what we can do is we can just add the power. So here it's going to be x to the power 4 plus 5, which just becomes x to the power of 9. Okay, 2 examples down, 2 more to go. Let's have a look at this one. So let me move it across so it's just a little bit easier for us to see. Okay, x to the power 3, y to the power 4 times x to the power 2 times y. Okay, now here, notice here we've got two sets of different bases. So here we've got x's, which have different powers, and we've also got y's with different powers. So for this question, we need to deal with each one of those separately. We need to deal with the x's by themselves first, and then we need to deal with the y's by themselves as well. So here, let's actually start off with the x's. Well, because I'm multiplying and they have the same base of x, I can apply the index law for multiplication. So here, I've got x to the power 3 times x to the power 2, so that's going to be x to the 3 plus 2. So I add the powers here. And the next part, I've got my y's. Now I've got y to the power 4 times y. Now if you remember what I said earlier, if you have hit this y, doesn't have a power attached to it. It doesn't have an index. So what this actually means is that it has a hidden index of 1. So here, this is just going to be y to the power 4 times y to the power 1. We've got the same base, and so we can apply the index law for multiplication. This just becomes y to the power 4 plus 1. Okay, cool, and we can start to simplify this. We've got x to the power 5, y to the power 5. Okay, so here with our index law for multiplication, all we do is we check which terms have the same base, and then we just add the powers together when we multiply. Okay, now the last question. Now here, we add on a few more things. So here, notice here, we've got 3m to the power 4 times 2m to the power 5. Now with this one here, notice we've got this these terms with the same base. So m has the same base as m. And so I can apply the index law for multiplication here. So what I'll do is I'd go, okay, m to the power 4 plus 5. Okay, so that will give me m to the power 9. But I've left this big gap here because there's something that we need to deal with. Notice here for both our terms, we've got numbers at the front. Because we've got numbers at the front, and they don't have the same base, we can actually deal with them and find out this numerical value. We're still multiplying. So at the front, all we need to do is just do 3 times 2. 3 times 2 will give me 6. And so here, my final answer is just going to be 6m to the power 9. So if you ever got numbers at the front, we can deal with them normally like we would with any other numbers, and we would just multiply them as they are. Okay, so this is how we actually apply this index law for multiplication. We check for the terms that have the same base, and then once we've figured out which ones have the same base, we just add the powers together when we multiply. So that's the index law for multiplication. Now, the next index law that we're going to look at is for division. Now, division is just the opposite of multiplication. So if we divide, when we multiplied indices, if we added the powers when we multiplied indices, then the opposite of adding is going to be subtracting. So here, when we have dividing terms with the same base, we subtract the powers. So what that looks like is if I have a term a to the power m divided by a to the power n, that just becomes a to the power m minus n. So when we are dividing terms with the same base, we just subtract the powers. Now, another way that you can write division is when you see a fraction, that just means that there's a hidden division operation. So another way that you might see this written is a to the power m over a to the power n. So if you see division, this is just and you see a fraction, that's just the same thing as dividing. We're dividing the numerator, the number at the top, by the number at the bottom. So let's actually go and apply this. Let's have a go at these examples. So the first two. So simplify the following using the index law for division. Leave your answer in index form. Okay, so let's have a look at the first one. I've got 7 to the power 9 divided by 7 to the power 5. Notice here, same base, great. All I need to do is just subtract the power. So here I'm going to have 7 to the power 9 minus 5. And so we have 7 to the power 4. Okay, so whenever you see division with indices and they have the same base, all we do is subtract the powers. So let's have a look at the next one. X to the power 10 divided by x to the power 2. Once again, they have the same base of x, and so we can apply that index law for division. So I'm going to have x to the power 10 minus 2. When I divide, I'm subtracting the powers. And so here, this just becomes x to the power 8. Okay, there we go. Now the last one is a little bit trickier. The last one is a little bit trickier. This one, we've got a fraction, and the fraction just tells me I'm doing division. So here, this is not very, it's similar to our first two, but here we've actually got a few other things included. So here, let's deal with our numbers first. So here I've got a to the power 6 divided by a to the power 2. So we're going to deal with only the terms with the same basis. So I've got a's over here. So we've got a to the power 6 divided by a to the power 2. When we divide, we just subtract the powers. And so I'm going to have a to the power 4. And I've also got my b terms, which have the same base. So here I've got b to the power 3 divided by b to the power 2. And so b, that's just going to be, actually, let me write the full working out. So that's 6 minus 2, and b to the power 3 minus 2. Okay, now what you've probably noticed is that I've avoided the numbers. Now, just like we did before with our numbers, what we can do is we can deal with the numbers like we normally would with just any other number. So this is just the same as doing 8 divided by 12. Now, 8 divided by 12, 12 doesn't go into 8 perfectly, but we can actually cancel out common factors from both of them. So here, I notice that actually 4 goes into both 8 and 12. 4 goes into 8 2 times, and 4 goes into 12 3 times. So here, for this one, this just becomes 2 over 3. So my final answer is going to be 2 over 3, a to the power 4, b to the power 1. Now, we don't write b to the power 1, we just write that as b. And so here, final answer, a to the power 4 times b. Now, another way that you can do this is when we are doing division, with fractions in particular, you can just cancel out common factors like we did with the numbers in our algebraic terms as well. So here, what I can do is I can go, okay, well, just like I did before, I can cancel that out. I've got 2 and 3 because I can cancel out 4 from both of the terms. Then I can go, okay, 6 divided by 2, I can cancel this out, and I'm left with 4 in my power. And here, b to the power 3 minus b, divided by b to the power 2, I divide, and so that means I am subtracting the power. So here I'm just cancelling that out, and I'm left with the power 1. And so here, this gives me 2a to the power 4b over 3. And that's the exact same answer as this guy here. These two are exactly the same. So that's the index law for division. When we're doing division with indices, we subtract the powers. Okay, now, what we can do with both of these index laws is we can actually combine them and apply our index laws to help us, we can simplify expressions by combining all of these index laws. So actually, let's have a go at doing that. Here, for part A, we've got x squared times x to the power x cubed divided by x to the power 4. Now, here, notice here, we've got the same bases. All of them have base x. So here I can apply both of those index laws. So here it's going to be x to the power 2. Now when we times, we add. So here this is going to be 2 plus 3. But when we divide, we subtract. So it's going to be x to the power 2 plus 3 minus 4. And so let's just deal with that. So that's going to be x to the power 2 plus 3. That's 5. Minus 4, that's 1. So that's going to be x to the power 1. Or just when we write this, we don't need to write that 1. And so this just becomes x. So here we can apply our index laws for multiplication and division, and so we just went from left to right there. Okay, let's have a look at this next one. Now this one, I've got a fraction, but at the top of my fraction, I'm actually multiplying. Now when I'm doing these questions, what I usually prefer to do is actually fix up the multiplying at the top before I do the division. So here, let's go and do that. So I'm going to deal with the top part. So here I've got 2 times 8. Let's deal with the numbers first. 2 times 8 is going to give me 16, and because I'm timesing, I'm just going to add the powers. So here, I've got a to the power 3 and a to the power 2. They have the same base. And so I'm going to add the power. So here this becomes a to the power 5. And just like I did for the other ones, I've got b times b to the power 3. This b has a hidden power 1. And so when I'm multiplying those, I add the powers. So that's going to be b to the power 1 plus 3, which is 4. And that's still being divided by 4 a to the power 4b squared. Okay, now that I've done that, I can do my division. Now, you can do this in one of two ways. You can just do regular division and go like we did in our first couple of examples, or we can actually cancel them out. So I'm going to actually do that step of cancelling out. So let's deal with the numbers first. Okay, 16 and 4, what numbers go into 16 and 4? Well, 4 can divide both of them. So here, 4 divides 4 one time, so I have 1 at the bottom. And it divides 16 4 times. Okay. Then I deal with my a's. Well, I've got a to the power 5 divided by a to the power 4. So here I just subtract the powers. So here I would go, okay, a to the power 4 goes away, and I'm just subtracting 4 from 5, and that leaves me 1. Okay. And once again, I've got b's which have the same base. I'm just going to do that subtraction again. So b to the power 4 divided by b to the power 2 just becomes b to the power 4 minus 2. I cancel that out, and I'm left with 2 here. So my final answer is going to be 4 times a to the power 1 times b squared. Now, whenever we see the power 1, we don't write that power 1, so this just becomes 4ab squared. Okay, so that's it for today's lesson on index laws. So let's just do a quick recap of what we looked at today. Today we started talking about index laws. Now, index laws are just patterns that we notice when we do operations with our indices. And the first one we talked about was multiplication. So if we multiply indices together and they have the same base, we just add the powers together. Nothing changes with our index, or with our base. All that changes is the index at the top. And so we went through a few examples of that. And we also went through division. When we divide indices with the same base, we subtract the powers. And so here we showed and we went through how to do that as well. And the final bit that we did was we can actually combine all those index laws that we looked at so far and create simplified expressions with both of those. So that's it for today's lesson on index laws of multiplication and division. If you have any questions, Year 9s, feel free to send them via email or leave a comment in our Google Classroom, and I'm more than happy to try and answer your questions. But until next, that's it for today's lesson. I'll see you in the next video. Bye.